All right, so now, yesterday we did a bunch of polynomials. The polynomials is x raised to a power. And so we looked at the differences of when we graphed an even power and an odd power. The only thing that we're going to do different today is that we're going to put a leading coefficient of, a coefficient of -1. Now, when we talk about transformations, if I say f of x is equal to a times x to whatever power, we'll just say 5, right? Then we know that if a equals -1, it flips the function, and we'll say over the x-axis. All your positive y values become negative y values. So what we would say is that transformation would be like g of x is equal to -x to whatever. Okay, yes? That's a good question. I don't know off the top of my head. It's 5.2. By the time I look it up, you'll probably find it. Whatever 5.2 is. Yep. All right, so let's just graph this and see what the end behavior is. But basically, all the graphs that we did yesterday, and all these graphs that we have here, we're just going to flip them. Okay? We're just going to flip them. All right? And so let's take a look at that and see what we see how that changes things. Did you find it in your book? Okay. So the first thing I'm going to do is I'm going to clear out my calculator, and I encourage you to do this on your calculators as well. I'm just going to hit -x. Oops, wrong thing. I'm just going to hit -x. Okay. Someone broke the calculator screen. Oh, okay. Well, just grab a different one. Okay. So now that's what that graph looks like. And what it did is it just flipped it. That's it. It just flipped it upside down. So let's go ahead and take a snapshot of that. Now this does change the end behavior. So I'm going to put this in here. So yesterday that was the other way around, right? So what it does is it just flips it upside down. So what's the domain on this? Well, the domain doesn't change. It's still all real numbers. The only domain restrictions that occur are usually you can't have 0 in the bottom of a denominator, and you can't take an even root of a negative number. While the range is from -infinity to +infinity. And then I said yesterday you come in from the bottom and go out the top, but when you have a negative coefficient, you come in from the top and you go out the bottom, right? So what does that mean? As x approaches +infinity, which is a fancy way of saying going to the right, your y value approaches -infinity, right? So as I follow this graph to the right, my y value goes down. Consequently, as I go to the left, as x approaches -infinity, f of x, my y value approaches +infinity. So as I go in this direction, I go up. Let's do negative x squared. Okay? I don't want to go too fast. Do you guys have that written down? Yeah. Okay. So now what I want to do is I'm going to go and just change this to x squared. So I'm going to go in here and I'm just going to hit my caret symbol and just put a 2 here, just like that. Hit graph. And it's just like yesterday's graph, except it's flipped over the x-axis. That's the only difference. So if you compare that to yesterday's graph, which was positive x squared, the only thing we did is yesterday it was up like this. It was like U-shaped like this. And then with the negative, it just goes upside down. Just flips like that. Just flips over the x-axis. Does that change the domain? No. The domain is still from negative infinity to positive infinity. Now the range changes a little bit here. What is my lower boundary? Well, it goes all the way from negative infinity in the y direction all the way up to 0. So it does flip the range, right? So yesterday the range, and let me just flip back and forth real quick. Yesterday the range was this. Today the range is this, okay? So it's just flipping about the the x-axis. That does change some of the information, basically just the range. The domains, for the most part, stay the same, though. Okay, and I'll leave that up there for a second so you guys can write it down. But here, because we're changing it, if you read it like a book from left to right, you start at the bottom and you go out the bottom. In other words, as x approaches positive infinity, which is a fancy math way of saying going to the right, your y value, or f of x, actually goes towards negative infinity. So that changes too. And as you follow the curve of the graph to the left, the y value goes down. Or, as x approaches negative infinity, f of x also approaches negative infinity. I'll give you guys a second to write all that down. It's a lot of information. We're graphing things, we're writing things down, we're sketching graphs, and you guys want to process it too and think about where this information is coming from. The good news is that after we're done with this section, we get to take a test. There's only 2 sections on this module.
Are we taking the test this week?
I don't know. We'll see how long it takes to get through these example problems. Okay? We'll see how long it takes to get through these example problems. 182 is the page we're on. See, I told you it'd take me a second to find it. All right, so let's do the next one. Same thing, except now I'm just going to change it to the third power. I probably should mention, remember that this is x to the first power, so this is an odd power. Those patterns are going to be the same. They're just flipped over the x-axis. This is 2. 2 is an even power of x. 3 is an odd power. So the patterns will look the same. We're just flipping them over the x-axis. So let's go ahead and graph that real quick. Go to y equals. Just move my cursor over to where the little 2 is and change that to a 3. Hit graph. It's the same graph as yesterday. We just flipped it vertically. We just flipped it like this. Okay? Remember, A also does a vertical stretch or compression. But when it's negative, it just flips it. The y value, or f of x, that was positive now becomes negative. And that's where that comes from. Are there any domain restrictions? No. The domain is all real numbers, so I'm going to say all reals. And there's a couple ways that you'll see this. Sometimes they'll say all reals. Sometimes they'll make an R with an extra bar. And you could write all real numbers too. But basically it goes from negative infinity to positive infinity. That's the x values, right? Remember that the domain is the x values. Some of you guys are probably just continuing on in your notebook from yesterday's chart, and that's fine too. Ooh, I don't know why I'm so tired today. Now, what about the range? Well, the range goes for all real numbers too. So the range can go from negative infinity to positive infinity. As x approaches positive infinity, f of x approaches negative infinity. So the end behavior flip-flops, obviously. And as x approaches negative infinity, f of x approaches positive infinity. So I'll give you guys a second to write that down. Sketch the graph, think about what we're doing differently. Today's lesson was brought to you by Strawberry Dr. Pepper. No? I'll get a cease and desist from Dr. Pepper. I had a student, her dad used to work for Contigo, and I drink coffee, and I think for Christmas they brought me a coffee mug, a Contigo mug, and so in my videos, if you look at my early videos, I'm constantly drinking from a Contigo mug. And they were joking and saying that Contigo sponsored my YouTube channel. And then the kids would ask me to give a shout out to Contigo and stuff. It was kind of funny. That's like when I first started doing this, I had a student, her name was Liz. She always wanted me to give her a shout out. She graduated probably like probably closer to 20 years, 15 years ago. I don't know. And now we give her a shout out all the time. The 8th graders, I told that story to the 8th graders. And so when I start recording, they go, shout out to Liz. It's kind of funny. Anyways, let's do the next one. So 4 is what, even or odd? Even. So what do we know about the even and odd patterns? Well, even looks like what?
Even looks the same as number 2.
Yeah. It's going to be kind of a U shape, but it'll be a little more square. The corners will be more cornered, not as round. Let's graph it. So I'm going to come in here. Also, another kid asked me why I made sound effects when I do math. And I was like, I don't feel like I should even have to answer that. So let's take a screenshot of that. Yeah, it looks just like the other one, but different, right?
So for all the domains, will it be the same point?
Yeah, so domains are, for the most part, almost always all real numbers. If it's a function, unless you have 0 in the denominator of a fraction. So if you have a rational expression and that has x in the bottom of it, whatever value for x makes the denominator equal 0 is no bueno. Also, if there's a negative value, in other words, if you're taking the square root or an even root of an algebraic expression that has x in it, any x value that makes it negative won't work either. So that's where you have domain restrictions. You can't have even roots of negative numbers, and you can't have 0 in the denominator of a fraction.
Pretty much we could plot the rest of the chart for domain and then the box, the column on the left, right?
Yeah, so okay, I gotcha. So the question is, well, basically this is going to be the same for all the domains, and my short answer is yes.
And then for the range, we're just going to keep on rotating them from 0, the little parentheses thingy.
Yeah. So if it's, yep, and that's why we did it this way, and I am very particular about not stating the pattern, because sometimes if you just do it over and over and over, the pattern emerges. Yep. So then, here's the thing. This approaches negative infinity and approaches negative infinity. So what the student is saying, and I don't know if the microphone picked it up, is like the even powers, the range is going to be the same. The end behavior is going to be the same, except different now because it's going in the opposite direction, right? We flipped it over the x-axis. So we don't even really need to graph it, right? We know that the graph, this is 5, which is an odd power, and we know that the odd powers are going to kind of have this S-shaped look, right? The odd powers are going to have kind of an S shape. It'll be a little different. So let's go ahead and graph that. So if I come in here and I change this to 5, and I hit graph, it's pretty much the same thing, but the same thing, it's not as curved. It's a little more squarey. I don't know if that's the right word. I'm sure there's a better word for that, but I'm trying to use terms that make sense to you guys. There is an actual fancy word. Sometimes I like to use fancy words, sometimes I don't. Now I gotta remember where I was. There we are. So yeah, this just looks very similar to the other odd power. Except it's not as rounded, right? This one is a little more boxy in the corners. Does that make sense? So if I compare this to this one, it's a little boxier. Well, I'll show you this. So this is x to the 5th power. I'm going to plug in temporarily x to the 3rd power. So if I say negative x to the 3rd power, there is a slight difference. Does that make sense? It's barely. But this is, so, we use this in the real world to demonstrate or make predictions on data. So if I had something that looked more like the blue line, I would say x to the 5th power. If I had something that looked a little bit more like the red line, I would do x to the 3rd power. Does that make sense? Let me turn that off. Okay, cool. All right. So yeah. So what's the domain then on this bad boy? Yeah. What about the range? Yep. This one approaches negative infinity. As x goes to the right, as x approaches positive infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x approaches infinity.
Is number 4 supposed to have a negative right there?
Here?
No, your little mouse is on the box to the right.
Over here?
Yeah.
No, because if you go left or right on the graph at all, it will always be a negative one.
Yeah. Yeah, so yeah, let me highlight that. I say it. This is always hard, the end behavior, because it's you have to so you decide where what you're doing with end behavior is trying to figure out what is y doing as you go along the graph in the x direction. That's kind of hard, right? So this first line here says as x approaches positive infinity. So positive infinity in the x direction is to the right. So as I follow the curve to the right, what is my y value approaching? Negative infinity. So now as I say x approaches negative infinity in the x direction is to the left. So as I follow the curve this way, what is my y value approaching? Negative infinity. And that was hard for me when I learned that too, because I was just like infinity, negative infinity, x, y, f of x. And when you do the f of x, that's a hard thing too. You got to remember f of x is the same as y. Yeah, it's confusing for sure. All right, next one we have an even power. Good question though. I'm glad you asked. I'm glad we were able to clear it up, hopefully. All right, that's an even power. What's that going to look like? Yep, this is going to go from negative infinity to positive infinity. What about this here? Including 0. That's why we have the bracket. And then this will be negative infinity and negative infinity. Because it's gonna look like this. Except better. It'll be symmetrical. But that's how it's going to look, right? So let's double check and see. So if I go in here and I change this to 6, and it's just going to be boxier. That's it. Does that make sense? I'm tired today. All right. Let me go back here so you guys can finish writing everything down. Now, I do have a question. It says, how can you generalize the results from x to the n and f of x equals a negative x to the n, where n is positive whole number? So how would you answer that? Basically, what patterns emerge?
All of the domain the same.
Yeah, so I'm going to try to squeeze this in here. Maybe I could type it. I don't know if I'll have room. We'll try to type it. Domains for all are, and I'm just going to put it in caps, all real numbers.
And then the range rotates.
So that's negative infinity to positive infinity. What's that?
The range rotates. Because all odd numbers have the same range, all the even numbers have the same range.
Odd powers have a range of all real numbers, positive infinity to negative infinity. Even powered even powers are restricted to 0, and I'm just going to say depending on A, right? And then in parentheses, I'm going to say f of x equals A times x raised to n. Are we leaving anything out?
The end behavior, the odd numbers have a negative infinity or positive infinity, while the even numbers are just of negative infinity.
Oh, okay. So let's
You just put end behavior positive.
so let's do odd power end behavior I'm going to say opposite. Opposite. I'm going to say are opposites. This is sentence fragments, but that's okay because I'm trying to make it all squeeze in. But even power and behavior are the same. And I'll explain what that means. So I don't know if I can get that to fit in there, the whole thing. Yeah, we'll see. So let me explain what I said. So the domains for all of them are all real numbers. The odd powers have a range of all real numbers. The even powers are restricted to 0 depending on A, if A is positive or negative. I should say depending on A. And then the odd power and behaviors are opposites. So if it approaches negative infinity on one, then it's positive infinity on the other, right? So see how, and let me show you that. See this odd power? It's negative infinity here, but positive infinity here. Now, but for the even powers, they're the same in behaviors. Now, if I change my A values, that still holds true, right? So if I zoom in, these are all the leading term A is positive 1, but it still holds true. Odd power, they have opposite end behavior. Even power, same end behavior. Opposite end behavior, same end behavior. So depending on whether it's flipped or not, if you go in from the bottom on an even power, you come out the bottom. If you go in from the top on an even power, you go out the top. For the odd powers, if you come in one side, you go out the other. Does that make sense? Anything else? Did I forget anything? I think the only thing is that if A is negative, it flips it. I don't know if we even need to mention that. I mean, we did, but that we should know that by now with our transformations, right?